Hello candidates, welcome back to Math Trockers. Before we solve this problem, remember when a curve is given parametrically, we don't differentiate directly. Instead, we use the chain rule. So today, we are applying this idea to a ZIMSEC June 2007 paper 1 question and see how it leads to tangents, normals, and coordinates or points. Okay, so we have the ZIMSEC June 2007 paper 1, which reads the parametric equations of a curve are x equal to sine phi and y equal to 1 minus cos squared phi. Show that dy dx is equal to 2 sine phi. Item 2, find the equations of the tangent and normal to the curve at the point Q where phi equal to pi over 6. Item 3, if the tangent and normal meet the y-axis at points A and B respectively, state the coordinates of A and B. In total, this was allocated 9 points. Cool. So guys, let's not waste time here. All right. So we are given the parametric equations. So this is number 11. So on number 11, the parametric equations are x equal to sine phi, then y equal to 1 minus cos squared phi, right? So when we differentiate sine, we get cos. If we differentiate cos, we get negative sine, right? So let's go ahead and on item 1, now we are given x equal to sine phi. We need to differentiate x with respect to phi, and we get cosine phi, right? Then here, y equal to 1 minus cos squared phi. So when we differentiate, right, this one is 0. Okay, then we drop down the power. Once we have power, we subtract 1, right? So it's always power trig. If we differentiate cos, we get negative sign, so this becomes positive sine alpha times the algebra, which is 1. So there is just 2 cos phi sine phi, right? So once we get those derivatives, we now want to find dy dx, which is equal to dy d phi divided by dx d phi, which is equal to 2 cos phi sine phi over cos phi, which is equal to 2 sine phi, right? So here we have shown what is needed, right? That was quick. Okay, so now we are moving on to item 2. So on item 2, we need to find, the equations of the tangents and the tangent and the normal to the curve at the point Q where phi equal to pi over 6. Remember our parameters, our parametric equations, x is equal to sine phi. So x equal to sine pi over 6, which is 30 degrees. So sine 30 is equal to 1 over 2. Then we do the same here. Y is equal to 1 minus cos squared phi. So it's equal to 1 minus cos pi over 6 squared, which is 1 minus root 3 over 2 squared, which is 1 minus 3 over 4, which is a quarter. So, right, our Q is equal to 1 over 2 and 1 over 4. So we need to find the equation of the tangent and the equation of the normal at the point Q. So at this point, which is 1 over 2, 1 over 4, right? So what it means is that we need normal, the gradient of the tangent. So gradient of the tangent, since it was 2 sine phi, it's going to be 2 sine pi over 6, right? Which is equals to 2 times 1 over 2, which is equal to positive 1, right? So here it is just 1, right? Then we also need our normal gradient. So normal gradient is equal to minus 1 over gradient of tangent, right? So which is equal to negative 1 over 1, which is just negative 1, right? So now let's start by finding the equation of the tangent. So to find the equation of the tangent, it's going to be y. So I'm going to use y minus y naught equal to mx minus x naught. So for the tangent, right? For the tangent here, it's going to be y minus 1 over 4 equal to gradient 1 x minus 1 half, right? So y is equal to x minus 1 half plus 1 over 4. So y is equal to x. So here minus 1 half is going to be minus 2 over 4 plus this is going to be minus quarter, right? So the equation of the tangent is equal to x minus that. Then equation of the normal. So the equation of the normal, right, is going to be y minus the same thing, 1 over 4 equal to negative 1 x minus 1 half. So y is equal to negative x plus 1 half plus 1 over 4. So y will be equal to negative x plus 3 over 4. So this is the equation of the tangent, and that's the equation of the normal, right? So now on the last part, which is item 3, if the tangent and the normal meet the y-axis at the point A, so tangent is meeting at A and normal is meeting at B. It's intersecting the y-axis at B. So remember, at the on the y-axis or the y-intercept, x will be what? 0, right? So here, when x is equal to 0, so y is equal to minus 1, 4. So the point A is 0 and negative a quarter, right? Then we do the same when x is 0 here, right? So y is equal to 3 over 4. So point B is equal to 0 and 3 over 4, right? So guys, that's all about parametric differentiation. So we are done with this. Remember, we need to do a lot of practice from different past examination papers so that we stay on top of the game. I will see you in my next video. Take care.